Welcome. Today we'll solve a problem about springs and work. We need to find the spring constant K, given that it takes 2 joules of work to stretch a spring from its natural length of 30 centimeters. Let's start by drawing our spring system. Here's our spring at its natural length of 30 centimeters. When we stretch the spring, it extends by some distance x. For a spring, the work done is related to the spring constant K and the displacement x by the equation. Work equals 1/2 kx squared. This comes from integrating the force F equals kx over the displacement. Now let's plug in what we know. The work is 2 joules. To find x, we need to remember that it's the change in length, so x equals the final length minus the initial length. Solving for k, we get that k equals 2 times 2 divided by x squared. To find x, we need to use our understanding of springs. The work done on the spring is stored as potential energy. This energy causes the spring to stretch until the force from the spring balances any external forces. In this case, the spring stretches until it reaches a new equilibrium length. Now we can calculate K. If we substitute back into our equation, we find that the spring constant K equals 4 newtons per meter. Remember that the spring constant K has units of newtons per meter, which tells us how much force is needed to stretch the spring by 1 meter. And that's our solution. We found that the spring constant K is 4 newtons per meter. This means that for every meter we stretch the spring, it will push back with 4 newtons of force.